In this video, I've put some practice questions on mechanical comprehension for you to prepare for the ASVAB test. A fish tank at an aquarium contains several cubic feet of water. 1 cubic foot of water is equal to 62.5 pounds. If the fish tank is 6 feet deep, 12 feet wide, and 13 feet long, what's the approximate pressure at the bottom of the tank in pounds per square inch? So we are asked here to solve for the pressure, approximate pressure in PSI or per square inch. So how do we do this? Now, to find the pressure or PSI, we must divide the tank's total volume by the surface area of the bottom of the tank. So we find the volume first. It's stated here that the fish tank is 6 feet deep, 12 feet wide, and 13 feet long. So let's say this is our fish tank. So it says 6 feet deep, so this is 6 feet and 12 feet wide, and then 13 feet long. Now, to find the volume, we just have to multiply the length, the width, and the depth or the height. So that would be 13 feet times 12 feet times 6 feet. And this would give us a volume of 936 cubic feet. Alright, take note that we are asked to solve for the pressure, and the pressure in PSI, let's say pressure P, this is just equal to the volume divided by the surface area. Now we already have solved for the volume of the tank, and we need to solve for the surface area. This is surface area of the bottom of the fish tank. Now let's solve for the surface area of the bottom of the tank first. So the bottom of the tank is this one. This is rectangular. So let's say we draw a rectangle here. So this is the face of, or the bottom of, the fish tank. So the width will be equal to 12 feet, and then the length is 13 feet. Now the surface area for this one is just the product of the width and the length. So that would be 12 feet times 13 feet, and this would give us 156 feet. Alright, take note that we are asked for the value of pressure in PSI, so means in pounds per square inch. So that means the volume should be in pounds, and then the surface area would be, this is square feet, in square inch. But we solved for the volume and surface area in cubic feet and square feet respectively. So we need to convert feet, this one, the volume, cubic feet, to pounds, and then square feet to square inch. Okay, let me delete this. We're given here that 1 cubic foot is equal to 62.5 pounds. So now we can convert 936 cubic feet to pounds. So that would be 936 cubic feet times 62.5 pounds over 1 cubic foot. and then the cubic foot unit here will cancel out. We'll be left with the unit pounds. Alright, so we just have to multiply 936 and 62.5, and this would give us a volume that is equal to 58,500 pounds. So this is the value of the volume in pounds. And now that we've already converted the volume from cubic feet to pounds, let's convert the surface area from square feet to inches, because we need pounds per square inch. Alright, so one foot is just equal to 12 inches. So now we can convert 156 square feet. So 156 square feet to inches. So this would be 12 inches per 1 foot. Then we square this, so we can cancel out square feet, this one. So this would become 156 times 12 squared is 144 square inch, and this is just equal to 22,464 square inch. So this is the surface area in square inch. Now we can solve for the pressure. So let me delete this. Now the pressure is equal to the volume. Volume is 58,500 pounds. Alright, divided by the surface area of the bottom of the fish tank, which is 22,464 square inch, and this would give us an approximate answer, which is 2.6. So let's check the choices here. So we don't have 2.6 here in the choices, and the closest is 2.5. Therefore, the answer is 2.5. And X is an example of what type of simple machine? Wedge, none of the answers, inclined plane, or lever. So an X is a classic example of a wedge. The well pictured above uses what type of simple machine to raise and lower a bucket? Wheel and axle, block and tackle, third class lever, or wedge? We are referring to this figure on the right. So the well pictured here uses a wheel and axle system. So the answer here is wheel and axle. The movement, the wheel becomes smaller than the movement on the shaft, increasing the force on the shaft. In the pulley system below, okay, here on the right, how fast does pulley D rotate if pulley A rotates at 100 RPM? So where is pulley A? So this is pulley A here. It rotates at 100 revolution per minute. And what would be the speed of pulley D? So this is pulley D. Alright, let's try analyzing this. So pulley D is larger than pulley A. A larger pulley causes a smaller pulley to rotate faster by the ratio of their diameters. So if pulley A rotates at 100 RPM, then pulley B, okay, let's solve pulley B first. Then pulley B rotates at 100, okay. So this is the diameter of pulley A for 4 inches, and then pulley B is 10 inches. So we get the ratio of their diameters and then multiply it by the rotation of pulley A. So that would be 4/10 times 100. Okay, this would just give us 40 RPM. So this is for pulley B. Since pulley C here is directly connected, this one, okay, C is directly connected to B, so it rotates at the same rate, which is also 40 revolutions per minute. So we can now finally solve for the rotation of pulley D. So pulley D will rotate at the ratio of the diameters of pulley C and D. So that would be 5/16 times the rotation of pulley C. So that would be times 40 RPM, and this would give us a value that is 12.5 RPM. So the answer here is 12.5 RPM. If a wedge is made longer relative to its height, how does the force increase? All right. So if a wedge is made longer relative to its height, so longer than its height. So a wedge converts horizontal force into vertical lift. Its effectiveness is influenced by its length and height. When the wedge is made longer relative to its height, that would be less steep, the slope decreases. So this means that for the same horizontal distance moved, the vertical lift decreases. Since the vertical lift is reduced, you need to apply a greater input force to achieve the same lifting effect. Therefore, the answer here is the amount of lift is decreased as the wedge is moved horizontally. So this should be the answer here.